shit quickly and do even more interesting queries. So that's the goal of Tracker, is to provide a service that lets you do that. It's not a new idea. In 1995, I think Microsoft started looking at doing something similar. We spent about 9 years on it before giving up in 2004. The reason for giving up, I think, is they didn't manage to make it efficient. It was in the betas of some version of Windows, and it was then abandoned because people found that it took up way too many resources and didn't seem to actually provide any benefit. So that project, they haven't really looked at it since. So meanwhile, in the free software world, Tracker is developed and works now, which is great. So I'm going to talk a bit about how you can use it. This is, I came up with a diagram, and we'll move on. No, I'll go through what each of the bits of the diagram are. So to interact with Tracker, there's a command line tool called Tracker, helpfully. And you can do a few different things with it. Is that text big enough? I'll make it a little bigger. Okay, so it has a help command, and then you can see the status of the processes, the services running in the background. It has some other fairly useless status information. And then you can get the information on a particular file. So if I ask Tracker, what do you know about this directory, for example, here's all of the properties of that directory, such as it is a directory and it was last modified here. And all the files that it's indexed, it can tell you something about them. So if I look at a random album, there's a playlist, and it tells you what the contents of the playlist are. It gives information on all the files that it's looked at. So it has a database of metadata that it's extracted from files, and the Tracker info command can let you get that info for a certain file. It doesn't automatically index everything on your computer. You can configure what it indexes. So some files it doesn't know anything about. This is the source for this presentation, for example. I guess I'm spoiling some of what's coming up by showing you the source. But it doesn't know anything about that file. And then if I tell it to index that file, I've given it the wrong command line, it's a bug. If I tell it to index that file, it queues it to be indexed. And now it knows about that file and extracted some useful information, well, maybe useful, such as it's a PNG file. It's got its size, width and height. It can handle a bunch of different types of file. It can also, there's a few other commands that you can do from here. You can run queries in either SQL or a higher level language called Sparkle. You can search everything it's got indexed. So if I search for hats, for example, it shows everything that it's looked through, which has the word hat in it. It seems to have some source code committed, and various random files. You can search for any term. And you can also tag things, which I don't really use this at the minute. Probably the interface is a lot lacking, but you can, for example, I can show what tags Tracker knows about. These are mostly random ones. It's extracted from PDF files, and then I can tag. I can tag this directory, for example, if I can remember how to use the command. So, what tags does this directory have? Nothing. And then I can say add the tag talk. And now if I look for everything that's tracked talk, if I'm still remembering how to use this command, if I look for everything that's tagged talk, it'll show me that directory, although it shows me the URN of it rather than the directory, which is a little unhelpful. But it can do, these are the various things you can do from the command line. That program itself isn't very smart. What it's doing is communicating with a central database called the Tracker Store, which actually holds all of the information it's queried. Tracker Store is a process that runs in the background. It's basically a thin wrapper over SQLite, which is who doesn't know what SQLite is? It's a simple SQL database which works really well for storing a small amount of data on a computer. One thing SQLite isn't very good at is having multiple processes writing to the same file at once. And so for that reason, rather than doing writes in process, there's a central Tracker Store process, and that's the only thing that writes to the database. And that's done because then it means we get better performance out of SQLite when multiple things are trying to write things at once. and you can talk to the tracker store. There's a few layers of how to talk to it and query it. It has a dbus interface, which you can query. There's then a C library called libtracker sparkle, which is just a C interface on top of the dbus one, and you can run what's called sparkle queries. So Sparkle is a query language, which I won't really go into now. You can also access it at an even higher level using an abstraction library called Grillo. And Grillo lets you, it's pluggable, and it lets you query documents of different types. So you can query all the videos from a certain data source, or all the audio files from a certain data source, and get information about them. So if you're looking to get started at querying things from Tracker, I'd suggest looking at Grillo, and only drill down to the lower levels later on. So that's the database part. Now, if you've used databases, you'll know that you need database schemas. And Tracker uses a pre-existing set of database schemas called NEPAMUC, which is, we're now entering the land of funny names. Anything with networked environment in its name is obviously a bad idea, in my experience. But NEPAMUC was a project to define a set of schemas for things you commonly find on a desktop, like media files and contacts, like people and photographs, things like that. It's kind of from the world of information science. So if you start reading too deeply into NEPAMUC, and you start reading about RDF, which is an abstract data represent format, you'll find yourself going a bit mad, because everything is written in very academic, very like data scientist terms, information, knowledge engineering terms. So it's actually, the concepts are quite simple. I'm not going to explain them here, but if you start looking at NEPAMUC and you start reading about RDF and you think, this is crazy, I'm not reading this entire specification, you don't have to. You don't have to understand all the fundamentals. The concepts are simple, and you'll find a tutorial somewhere on the web that explains things in in 10 lines of text, and you'll think, oh, that was easy. So NEPAMUC basically provides the database schemas, and you can browse them using dev-help, which is a good way of browsing all known documentation. So if you look at the ontology reference manual, ontology, by the way, is a word which basically means schema. In this context, it doesn't mean schema, it's a different word, but you can use them interchangeably when you're thinking about Tracker. So, just as an example, here's the multimedia ontology, and it has classes to represent like a music artist. You can represent a video, and then it has attributes of the video, like how long it is, what episode of a TV show it is. And there's loads of these. Have a look through them either online, I think they're online, or you can view them in dev-help. That's NEPAMUC. And then, so we have this database, we have schemas for it. We need some way of getting information into it. Now, applications can store data in the Tracker store directly, and some do, but all the existing files on your file system need to get in there somehow. So there's two processes called the Tracker file system miner and the metadata extractor, and those run in the background, and when they first run, they crawl everything they find in your file system, not everything they find, but a set in certain directories, and extract whatever information they can from them. And then they monitor those files so that when you make changes, the database is updated in line. And then there's also a separate set of miners called the GNOME Online miners, which can fetch information from things like your Google Documents, Facebook photos, Flickr photos, and things like that. So you can then look in the Tracker store, then gets a picture if you've connected GNOME to those platforms. It then gets a picture of what documents you have in different online services as well. So I think that's the last bit. Yeah, there's the diagram again. Hopefully it makes a little more sense now. On the left is this part which is looking in the file system for data. Those two are the different processes responsible for doing that. Here's the Tracker store, which is the database, which has all the metadata in. And down here is where the Tracker binary I showed you fits. So how can you actually use it if you don't want to just search for things on the command line? Well, there's a graphical search tool called Tracker Needle, which looks like this and will let you, it's very simple, it lets you search for things in the Tracker database. There's Nautilus, I think now its search function can use Tracker as well. And I think the GTK file chooser is gaining support for it when it's available. There's GNOME Documents, which gives you a view of all the documents in Tracker. There's GNOME Music, mine was empty, but GNOME Music gives you a view of all the music. GNOME Photos shows you all the photos, hopefully more in future. Grillo is the abstraction library I mentioned before. So this app is just a demo. You can run it if you have Grillo installed, Grillo Test UI, and see all of the data you can see with Grillo, but it's not very pretty. But it's intended for you to write programs in C, Python or whatever, and query data and show it. I think one of these, GNOME Music actually uses Grillo. These two use libtracker Sparkle directly, I think, and GNOME Music uses Grillo. Either approach is valid. I think the Grillo approach is easier. But on the other hand, Grillo is still, I think, version 0.2. So you may find yourself fixing bugs in Grillo if you use it heavily, which is a good thing, but it may be aware of that. So I did another diagram, which I don't know how helpful it is, but this shows you the wider ecosystem of how Tracker's used in GNOME. So data comes in from the file system, it comes in over various network services if you've connected them in GNOME Online accounts, and then you can view it in these different applications. And please add more under here. There's users outside GNOME as well. The only one I know of active at the moment is Yola and their phones. Does anyone still have a Nokia N9? If you, brilliant. So Jeremiah's phone still uses Tracker as well. And there are probably others. I've definitely worked on projects which were trying out Tracker. Neither of the ones I worked on made it to production in the end, but it's certainly possible. People look at it. I will mention there's a project called Light Media Scanner, which is much more lightweight than Tracker and can do some of the things it does. So it can scan content and stick it all in a simple SQL database. And if that's all you want, use that. If you want more advanced querying and searching and desktop integration, then look at Tracker instead. So that's the first part of the talk. I'm just going to take a quick drink of water. How are we for time? About halfway through, which is great. So I'm now going to talk about what's good and what's bad about the current implementation. So like I said, I really want to start a conversation about search and indexing in GNOME and content. I've shown what we have at the moment, and the implementation works, but it definitely has some problems. So, good things. It sits on top of the existing file system. You don't have to sacrifice anything to use it. There's no, oh, here's a new file system. Just copy all your data into that, and it'll work much better. I don't think that's a sane plan for implementation. So that's a really sensible part of the design. It reuses SQLite, which is also really sensible because SQLite is massively widely used, well maintained, tested. So using that as a data store is sensible. It does mean we have some limitations because Tracker stores data using a much more flexible data model called RDF that I mentioned before. And trying to store RDF in a relational database like SQLite is tricky, and there are some compromises. But on the other hand, we get to reuse SQLite. There's also, I think Tracker started in 2004, maybe, and has changed drastically over the years, but that's now over 10 years of work on testing, desktop integration. There was a period where Nokia were funding about 6 people full-time on fixing bugs in Tracker and making it more efficient. So it really is battle-tested code. And one thing I really like is the interfaces between the components are well-defined, because it uses a defined data model and a query language, which is a W3C standard. So Sparkle and RDF come from the World Wide Web Consortium, and they're already defined standards. So the API surface over dbus and in the C library of Tracker is actually really small. There's only libtracker Sparkle maybe has 10 or 20 functions, I think. So compare that to GTK, which has thousands. It's much easier to maintain Tracker and keep it API stable because the actual interface you use mostly is the query language, and that is already a standard. So there's no question of, oh, should we change it to do this? It's more a question of, are we following the standard correctly? And this isolation means you could actually, I'm going to talk about this a bit, well, I can talk about it now. So the tracker store process could be replaced with a different data store. There's one called Virtuoso, which the KDE guys used and had absolutely no luck with. But theoretically, tracker store could be replaced with Virtuoso. There's also a new graph store which was recently made free software called Forstore, which I really want to look into. And again, it may be possible to completely replace this part of tracker with Forstore, delete a big chunk of the code, and that would be great. So I hope to spend some time soon looking at Forstore. And that's possible because it's well isolated and well designed. And none of these minors would really need to change if we did that. So onto the bad stuff. Running a search and indexer tool in the background is always going to have some cost on resources. And there is always going to be a compromise with that. Tracker didn't really help this for many years, up until the 0.16 release, there was a bug which could cause the file system miner to get in a busy loop. So it would use 100% of your CPU spinning through a queue forever, which has at least contributed to the reputation that it's inefficient. I don't think it does that anymore. I've not seen it do that for years. And if you can show me tracker using 100% CPU, then I'd like to see it and try and fix what's happening, as long as it's beyond the 0.16 release. There are still some performance, there are places where performance isn't ideal, but actually the database is quite efficient. It's been well optimized, and it's a fairly simple layer over SQLite. And so it's simple, but on the other hand, it's quite dumb as well. So Sparkle is a declarative query language, and you can write queries in all sorts of ways, and some of them, if you query a massive set of data and then filter it down to a tiny set, the tracker store won't optimize that, and SQLite probably won't optimize that either. So you'll end up generating this massive set of data in memory and then picking one thing out of it, and it will take a long time. And if you wrote the query the other way up, and you queried a small set of data initially, then it would actually be really efficient. So that's kind of a problem in the implementation, but it's hard to solve because writing and maintaining a query optimizer is a really difficult piece of work. So if you have problems with the tracker store, probably it's not that the store is just inherently inefficient, it's that the query is written in a way that it doesn't optimize. The miner, on the other hand, the miner is actually written to be fairly efficient as well. It is really asynchronous and will kind of give time back to the operating system whenever it can, which has the downside that the code's really complex, which is how it got such a terrible bug for a while, where it started spinning on queues, because there's all sorts of queues and all sorts of asynchronous callbacks. It's really bad spaghetti code. If you've ever dealt with glib code, which has lots of main loop callbacks, you'll know what I mean, that it's very difficult to actually reason about what's going on. Also, recursive file monitoring at the minute in Linux is impossible to do, at least if you're not running as root. So Tracker kind of fakes it using the iNotify API, which slows things down. The more files it's monitoring, the more iNotify watches it takes. And that's not how the iNotify notification API in the kernel was actually meant to be used. Fixing that requires probably not some very fun work of trying to fix the API in the kernel. So at the minute, basically there's a kludge in the miner that it uses iNotify in the wrong way, and help fixing that would be much appreciated. I've mentioned how the code of the miner is too complicated already. And also, the miner it doesn't have any smarts about ignoring large sets of files. So the worst case of this is when you have, say, a Git repository checked out in your downloads directory, and it will index every file in that repository, which probably isn't what you actually want. And to avoid that, the default configuration of Tracker is not to recursively index your full home directory, but to just look at the top level of files in the home directory, and then look at the videos folder, the music folder, the documents folder, the downloads folder, with the hope that if you're an advanced user with lots of source code checked out, you won't keep it in your downloads or music folder, you'll keep it somewhere else. So the default configuration is intended to kind of work around this problem. But if you do like keeping huge checkouts of source code in so the music folder, then tweak the configuration of tracker. It would be great to make it smarter and ignore things that probably people don't want to be indexed, which would be a matter of working on the minor. Change notification from the database is difficult. It's possible, and I noticed in Grillo that it does have code to watch the graph updated signal that the store emits. So that's great, but if you try and watch it yourself, you'll think, okay, what I wanted was some data, and instead you've given me 4 numbers. And so you then have to query tracker and ask it, okay, what do these 4 numbers actually mean? Which is fine unless it's telling you that something was deleted, because at that point the numbers won't be in the database anymore, so you can't query it and find out what they mean. So watching for data, it's possible, all the bits you need are there, but they're very difficult to use. And so if you're trying to write something directly on top of the tracker dbus API, you'll hate the author of that signal and wish that they'd done more work for you to make it easier. Finally, the way that we have an RDF store implemented on top of SQLite means that the schemas or ontologies are really tied to how the data is stored. So, say you have a property which has any number of possible values. Say, for example, a piece of music can have any number of artists, and then someone changes the ontology so that a piece of music can only have 1 artist, and you have a song already in the database with 10 artists. Once it processes that update to the schema, which one does it pick? There's no real way of knowing which value of a multi-valued property is the right one. And so I think what the tracker store would do in that case is refuse to do the migration and say, well, actually, I don't want to change the schema in that way. And that's basically a consequence of the way it's designed. Separating the data storage from the schemas would solve that. I don't know how it would affect the efficiency or the implementation, though. So at the moment, we deal with it by not doing certain types of changes, which in practice isn't that bad, but it's a consideration. So that's, this is the last section of the talk now, in which I talk about what I think the future of tracker should be. So we could give it up and start from scratch, which I think is a terrible idea. Throwing away 10 years plus work is never a good idea. We could look at what other people are doing. So KDE have a sort of parallel history where they developed something that didn't really share any code with Tracker, but did similar functionality, and they approached it in a different way. Instead of writing their own data store, they used a pre-existing one called Virtuoso, which is a huge monster of a database which claims to be able to store every type of data in every way and also be a web server. And on top of that, they had an abstraction layer, of course, called Soprano. So the end result is that this wasn't ever particularly efficient, and there were lots of complaints about it in the KDE community, from what I understand. They also had the equivalent of the miner and the extractor in KDE was a process called Nepomuk, which is confusing because Nepomuk is also the name of the database schemas. And they've abandoned that approach now, which isn't to say they've thrown away all of the code, but they've abandoned the idea of using a generic data store. And instead, they have a new project called Baloo, which I think is now released in KDE 4.13 and beyond. So we can keep an eye on it and see how much it works, how well it works for them. I've already found some angry blog posts about how I need to disable this and everything else, so it obviously hasn't solved the problem that some people don't like indexing frameworks running in the background. But the approach they've taken is have a pluggable backend for storage. So rather than trying to fit everything in one database, you can, well, I need to read it more on how it works, but you can, for example, for indexing text documents, you can use Zapier, which is purpose-built for that. For things that fit in a relational database, you can use SQLite. For storing emails, you could store them in an Mbox file, for example. We need to keep an eye on Baloo and make sure we can learn from it, and we learn from it as much as we can.
Sam, have you looked at Sapien directly for plugging into Tracker?
I've not. SQLite has its own full text search feature, so we use that at the moment. It might make sense, I don't know. So what I think we need to do is define the scope of what we want from Tracker, or if something replaces it, what we want to replace it. In the past, we've kind of said that it can do all of these things. So it's primarily an indexer, but applications can also store their own data in it. You can store remote content from it if you want, and you can store any kind of RDF data in there you want, theoretically. There's a few problems with that, which is it behaves like a metadata cache. The Tracker database at the moment lives hidden in your cache directory, which is only really suitable for data that isn't valuable. There's also a command in the Tracker tool I showed you earlier. There's a Tracker reset command, which basically means delete all my data, which is fine, again, if it's all cached information. It's not fine if it's all your contacts and all of your to-do list items are stored directly in there, and that's the canonical storage location. So I think the easiest way to fix this is don't do these things and store data outside Tracker as well. So for example, if you want contacts to be indexed in Tracker, store them in Tracker so they can be used, but also store them in a more suitable storage format. Store them however Thunderbird or Evolution stores them. Store them in Evolution Data Server perhaps as well, because that's not a cache, that's an actual data store. This is just my view, by the way, but this is the most sensible solution, I think. The other way involves putting more and more data into a binary file, which I'm generally against because it's much harder to debug and to look at. So there aren't many people working on Tracker at the minute. Martin Russell still works as a maintainer when he has the time. Carlos, who's sat over there, also does a lot of work on Tracker. Quite a few people from GNOME send patches, which is awesome. People fix issues as they find them. But it doesn't have there's no full-time funding for the project at the minute, which means there's not really any room for doing big changes. If we're going to improve things and we're going to change things, they need to be small plans, doable in over a long period, or doable in a couple of days, because otherwise they'll just be left as loose ends. So I'm going to finish the talk with a few ideas for things that I think are small items that could be fixed. The first one is that recently the Tracker miner, the file system miner, grew an abstraction point, this one which I've coloured in green, called Tracker enumerator. Because the file system is basically a tree. And lots of other things are trees as well. So since a list is a tree with depth of 1, any data really is a tree. And so the code in the file system miner for crawling a tree can actually be used to crawl any kind of tree. It could crawl your emails, it could crawl photos on Facebook, it could crawl YouTube videos. And the Tracker enumerator extension point allows you to implement an enumerator which will crawl through a tree of any abstract data. So it could crawl through videos, photos, whatever else. Which means the file system miner suddenly has the wrong name. It can do much more than mining things from the file system nowadays. However, there's already a project to do that. GNOME Online Miners is about 5,000 lines of code, which already mines data from online sources. And then there's Grillo, which doesn't insert data in Tracker, but does know how to talk to all sorts of online services, some of which overlap with what GNOME Online Miners can crawl through. So at this point we have 3 kind of points of abstraction, and we really need to merge them together and basically delete some code. Deleting code is great, it means we have less work to do. So I don't have a heart set on which is the best solution yet, but I think that updating GNOME miners to make use of the code in the Tracker file system miner, and perhaps make use of the code in Grillo as well, would be a really useful project. And we could probably delete a lot of GNOME Online Miners and make them much simpler, and make it really easy to add new miners to that, which would be great, because the more data we can browse, the more fun it is. So that's one idea. This needs to be done. It's not really a fun weekend hack, but hopefully someone who knows how to write new kernel monitoring interfaces will be able to do it. I certainly don't have the capabilities at the moment. There are several existing projects that I think it's worth looking at. I've already mentioned Forstore, which could perhaps take over the role of Tracker Store. I've already mentioned Baloo, which is doing a similar thing with a different implementation. I also recently realised that Elasticsearch, which is a massive, I think it's Apache project to search huge sets of data. It's used by big websites with tens of terabytes of data to search through. Elasticsearch actually does some similar things to Tracker, and aligning with the way Elasticsearch works might be really useful. So it has an API which uses a simple JSON structure to query data rather than the Sparkle textual query language. They really map down to the same thing, but maybe the Elasticsearch way is worth investigating. Elasticsearch also makes it very clear that it's not for storing data. It says, there are big warnings saying do not store any data in this. It's purely for indexing things. If it's your primary data store, you'll have nightmares and things will go wrong. And I think what I meant when I said about defining the scope of Tracker, that's where that came from. I think that limiting it to indexing would make it more like Elasticsearch and more suitable for just one purpose. There's been a bug on Bugzilla for about the last 3 years now to do opt-in scanning of removable devices. I don't know if Felipe is here, but Felipe did a Summer of Code project several years ago to implement this, and it's nearly done. The idea of this is that if Tracker scans every device which is plugged into a computer, it becomes really annoying because maybe it crawls your music player and indexes all your music, and that's great. And then maybe you plug in an external hard disk with 50,000 files in, and it starts crawling all those, and that's really annoying. So it can only really work in an opt-in way. And so this was a project to add a way that apps could say, for example, known documents could say, I can see that you've plugged in a memory stick. Should I index it, or should I get Tracker to index it? At the moment, scanning removable devices is disabled to avoid the case of you plug in a hard disk and it eats CPU for the next 3 days and wears out the hard disk. So opt-in scanning would be really useful to allow Tracker to scan removable devices again without becoming really annoying. There are some plugins in the source tree for extracting things like emails from Evolution and from Thunderbird and bookmarks from Firefox. Those go out of date really quickly. So bringing those up to date would be really fun and really useful. Improving the documentation on the wiki would be great because a lot of it dates from a few years ago. There's a roadmap, for example, which is mostly things that have been done several years ago, which is great, but it's not that much useful information anymore. So bringing the documentation up to date would be great. There's a test suite, which there's a set of C tests, which are great, but only test a limited set of the functionality. And then there's what are called the functional tests, which are written in Python and kind of do black box testing. And those are great, but they're quite old, and they have a problem in a few cases. Some of them fail, and some of them sometimes fail and sometimes pass. So over the past couple of years, I've tried to get them into shape so that they always pass. And at that point, we can use the install tests feature of known continuous and start actually doing continuous testing of Tracker, which will be great. And as soon as we stop getting false positives or false negatives, we can do that. And we can then start extending the tests and make some more realistic scenarios to test that the things that the really annoying failure cases don't happen anymore. So that would be really good. There's a few cleanups in the build system that need doing. If you read Philip Widnall's blog, you'll know that known common can now be completely removed, and GTK-doc can now automatically substitute the package version in documentation. So there's some really easy fixes that can be done in the Tracker source tree and be really useful. And that is everything I had to say prepared. So thanks a lot for coming and for listening. Like I said, what I want to do is start a discussion about search and indexing. So I think we've got some time for questions now. Or come talk to me, talk to Carlos, talk to random strangers in the pub about search and indexing. And that'll be great.
I have a question.
Brilliant. Are we going to do questions with the microphone, or should we just shout them?
Yeah.
Okay.
We can do a track.
Let's see if it's on. I can't work out how to switch it on. I'll leave it to you.
I can shout. Well, if we use the mic, then the people
Yeah, I have to
who are
repeat
watching
it if we don't have a mic, and I'll get really
I can
confused.
shout.
Okay.
So, one current problem that has shown up recently is sandboxing. because I guess Tracker was built to do kind of cross-domain kind of queries, like you have this global set of data, and you ask things like, when did this contact give me this photo or something like that. But in sandboxing, you really want these domains to be separated, and you don't want. I mean, you don't want to let apps to access each other's data unless.
Yeah, that's a really good question actually. Something I didn't touch on in the talk, and so the context is Tracker Store at the moment stores everything. All your metadata goes in one big database, which means that if something can run queries in the database, it can access all your data, which is probably not what you want. I don't have any answers on how to fix this. There's a few possibilities. It can either be fixed at the level inside the database. So you can, in an RDF store, you can put the data in different compartments. Confusingly, they're called graphs, even though almost everything is called a graph in that world. But it's often called having named graphs. So you can say, okay, these contexts go in the work graph, for example. These contacts rather go in the work graph, and these contacts go in the personal graph, and I only want this app to be able to see the personal graph of my contacts. That's not something the Tracker Store can do at the moment. It might be something that a different data store could do, but that's one way of solving it. Another would be to do what Baloo is doing and actually store the data in separate files. From the point of view of making an interface to this, that's kind of the same approach. I think one of the hard parts is defining how users actually see this interface, because users will not want to say, this app can see graph 1, 2, 3, 4, 6, 8, 7. They want a more meaningful thing like, do you want this app to be able to see all your data or some named subset of your data? And so I think probably the way forward is to define how we want the interface to look for the user. That may think about designing a portal, for example, and then thinking about how to implement it from there. So, yeah, I don't have a solution, but it's a really good question and something we need to think about.
I would like to add that we need first to identify the granularity of the data we need to isolate. If you want per graph, we'll mostly there. If you want per class, it will be considerably harder, and if you want per row, pretty much impossible. So,
I guess going by the current use of Tracker, it's like, no, I mean, I guess we want something like this application only should see my music. This application should only
yeah,
see
but
my
then that's tricky because then the music is linked to contacts, which are the artists, and those could be perfectly contacts from your artworks.
That's a useful starting point, though, the idea that, yeah, documents should only see documents, music should only see music. That's a good starting point to think about how to solve this.
Yeah. Did you say in the beginning that running as root you can, in fact, do efficient recursive iNotify?
I've heard that, yes. It might not be true. I haven't investigated this.
Okay. So if you found it acceptable to run a minimal daemon that does nothing but forward those notifications to Tracker, then that might be a solution.
Yeah, that's a good idea.
Yeah, but well, ideally it would depend on the kernel. The thing is with iNotify is that it doesn't scale within the kernel because yeah, well, you pretty much.
Do you want the microphone?
Yeah, better, I guess. For the future. So the thing is that iNotify implementation is just not thought out for this kind of behavior. It's thought out for maybe one handle on one file, you monitor one file, one directory, but it's not thought out for mass listening across trees. So one solution is having a separate service, but one thing that could look promising is iNotify, which is already more or less able to notify across trees. And yeah, but it's not easily adapted to Tracker world first. obstacle is that it's sysadmin only, so you don't we don't have access from there, and we're having a daemon which is root only to notify about files is also a bit dubious. It would be great to identify which is missing in FileNotify so it can be just made available to every user.
Yeah, it's an idea, as I said, if you find it acceptable. It wouldn't do anything else than send information. Hopefully.
Yeah, that's
It would be a very minimal implementation, obviously. But sure, maybe the proper fix is coming in the kernel.
I don't know who's doing it, but we all have hopes.
Okay, we have another question.
I have a question about the UI of Tracker, because I have the feeling that a lot of people don't know that when they have a GNOME desktop, they have a Tracker and a search, an indexer available, because if they want to search for something, these days they would search in GNOME Shell, and unfortunately we don't have, as far as I know, a search provider for Tracker in the shell.
Yeah, that's true. And a logical way to solve that would be write a search provider. But it's it comes up against a problem that the shell has already taken this federated approach, which is kind of the Baloo approach of having multiple search providers. And so a tracker provider would have some overlap with those. So I definitely think it's worth writing a shell search provider. But I think that wouldn't be a solution in and of itself, because you then have multiple results for some things. And then if people removed the search provider, I mean, if we removed some of the shell ones and just had a tracker one, then it starts depending on tracker, which makes some people angry. So I don't know what the best answer is.
Although I would like to point out that although some of the current GNOME shell providers do already hit trackers, so it's kind of already there.
Oh, right.
I mean, the GNOME documents search provider, the shell search provider for GNOME documents is basically talking to tracker, and same for photos. And I guess music would do the same to Grill or this and that.
Right. So it may actually be more efficient.
I'm
to
not
replace
sure
them with
what
one.
Nautilus does, but I know that it uses tracker for its in-application search. So maybe the shell search provider is also using that.
Yeah.
It's kind of already there behind the scenes.
Do you think it's a problem that users don't? So if your average GNOME user doesn't know what tracker is that a problem? I mean, for me, I think of it as middleware, really.
I would say it doesn't matter if they don't know about Tracker. It's just that if we get, for instance, having Nautilus and the search provider of Nautilus plugged into GNOME Shell, and if it uses Tracker behind the scenes, it's great. Just that at the moment there is a gap somewhere, and we just need to fill this gap either with a Tracker search provider, but it might be overlapping as you mentioned, or we just add the missing bits so that all the search providers which are already available are powerful enough so that users can have a search experience.
Yeah.
Any more questions? We can then wrap it up. We have a small thinking gift.
Brilliant. It's all been worthwhile. Thank you.
Ja, vad bra. Hur är det för dig? Är det? Okej. Ja, faktiskt. Ja.